Welcome to The Explainer. Today, we're unpacking what is honestly a true high-stakes geopolitical thriller. We're looking at India's multi-billion-dollar bet on the absolute tiniest, most complex pieces of technology ever created by human hands, microchips.
Okay, let's dive right into this. Here's our roadmap for today. First, we'll cover the new steel, then look at a history of missing the microchip bus. After that, we'll break down the India Semiconductor mission, explain why domestic manufacturing matters, explore building perfect factories, and finally, look at how design meets manufacturing.
Section 1. The new steel. Semiconductors power the modern world.
Before we talk about the mission itself, we really have to understand why these microscopic components are the absolute, undeniable foundation of modern life. You know, you've probably heard the phrase that data is the new oil. Well, if that's true, then semiconductors are absolutely the new steel. Without them, the entire modern infrastructure of our world just completely halts. We're talking about everything from that basic toaster sitting on your kitchen counter right now to the highly advanced Agni missile systems protecting the nation. Every single one of them runs entirely on microchips. And just to put the sheer scale of this reliance into perspective for you, a modern electric vehicle doesn't just have one or two chips. It relies on literally thousands of them just to manage its battery, the sensors, and the navigation. It's wild.
And that brings us to the India Semiconductor mission, or ISM for short. So what is this exactly? It's a specialized business division built right within the Digital India Corporation, and its sole objective is incredibly ambitious. They are looking to build a vibrant semiconductor and display manufacturing ecosystem in India completely from scratch. And they're backing this up with some truly staggering financial commitments. The government recently approved nearly 1.26 lakh crore rupees, that's roughly 15 billion US dollars, for massive new fabrication or fab plants as well as ATMP facilities. Now, ATMP stands for Assembly, Testing, Marking, and Packaging, which is basically the crucial final step before a chip goes into a device. These huge facilities are being set up right now in Gujarat and Assam.
Section 2. Missing the microchip bus. A history of missed opportunities. To really appreciate the scale of this new mission, we have to acknowledge the absolute vulnerability that brought us here in the first place. Right now, India is 100% reliant on importing these critical chips. Back in the 1980s and 90s, India completely missed the semiconductor manufacturing bus, basically allowing countries like Taiwan, South Korea, and China to absolutely dominate the global supply chain. And this total reliance on imports? Well, it became a full-blown crisis during the COVID-19 pandemic. The global supply chain experienced a massive shock. Automakers right here in India literally had tens of thousands of unfinished cars just sitting in massive lots, gathering dust. Why? All because they couldn't import a tiny $2 microchip needed for their dashboard displays. This was a huge wake-up call, and it led to an equally massive pivot. In 2021, a 76,000 crore rupee production-linked incentive, or PLI scheme, was announced to heavily incentivize manufacturers. And guess what? It worked. It led directly to the 2024 approvals of major fab plants by legacy companies like Tata and CG Power.
Section 3. The India Semiconductor Mission Explained. The bold pivot to domestic production. So let's look at exactly how the government and these massive conglomerates are urgently fixing this import dependency through major global collaboration. We've got domestic stakeholders like MITI, that's the Ministry of Electronics and Information Technology, working alongside legacy Indian conglomerates like Tata and the Murugappa Group, but they aren't doing it alone. They're partnering with global heavyweights from Taiwan and Japan. Together, they're pouring resources into massive facilities in Dholera, Gujarat, and testing plants in Assam. This right here is a true synergy of domestic capital and foreign technological expertise. And that is such a vital point to remember. This isn't just about throwing money at a problem. It's about importing decades of fiercely guarded proprietary knowledge and manufacturing expertise from Taiwan and Japan that India currently lacks. Section 4. Why domestic manufacturing matters. The strategic impact. Now, what's really interesting about this next point is the sheer scale of the economics involved. We know what the mission is, but let's pivot to the crucial takeaways for national survival and economic health. The biggest takeaway here is a single glaring number: $24 billion. That is the staggering value of semiconductors that India imports annually. I mean, it is a massive drain on foreign exchange reserves. So manufacturing these domestically isn't just about showing off cool tech. It's about fundamentally fixing a massive leak in the country's import bill. Keeping that $24 billion within India's borders radically transforms the domestic economy and strengthens the currency. So the strategic impact is really built on three main pillars. First up, Supply chain security. Taiwan currently produces over 60% of the world's chips. If a geopolitical crisis occurs in the South China Sea, say a blockade in the Taiwan Strait, the global economy collapses instantly. And that doesn't just mean a delay in getting the newest smartphone. It means critical national defense systems simply cannot be repaired or upgraded. Local fabs protect India's defense and civilian industries from being paralyzed by that kind of catastrophic event. Second pillar, high-tech jobs. A single fab plant creates thousands of direct, highly paid engineering jobs, plus tens of thousands of indirect jobs in chemicals, infrastructure, and logistics. And third, like we just established, import substitution, plugging that massive $24 billion annual drain. Section 5. Building perfect factories, creating a flawless industrial environment. However, and this is a very sharp however, guys, it is one thing to allocate massive financial investments. It is an entirely different, incredibly intimidating reality to actually manufacture these chips. Standard factory settings are tough, sure, but a semiconductor fab plant, it is arguably the most complex manufacturing process on planet Earth. You are literally manipulating materials at an atomic scale. We're talking about carving intricate electrical pathways that are thousands of times thinner than a single human hair. And remember, India isn't just competing with itself here. It's competing directly against the United States with its massive CHIPS Act, along with heavy tech subsidies from Europe. They are all fighting for the exact same talent and technology partners to build these hyper-advanced facilities. Just look at the absolute perfection required here. Step 1, you need 24/7 completely uninterrupted power. Step 2, millions of liters of ultra-pure water every single day. Step 3, a zero-dust environment. And to put that into perspective for you, a zero-dust environment means the air in a fab is tens of thousands of times cleaner than a hospital operating room. A single speck of dust landing on a wafer during production is literally like a massive boulder crashing into a microscopic city. It completely ruins the entire architecture. Even a microsecond power fluctuation can destroy millions of dollars worth of silicon wafers instantly. Creating and maintaining this flawless, delicate industrial ecosystem is going to be India's biggest test by far. Section 6. Design meets manufacturing. India's hidden advantage. Let's look to the future outlook now. The immediate goal is to start by manufacturing 28-nanometer chips. These are the kind utilized in cars, telecommunications, and your standard household appliances. But the ultimate target for the coming years is to eventually manufacture the incredibly dense, highly advanced sub-5-nanometer chips used for supercomputers and artificial intelligence. And this brilliantly illustrates India's ace in the hole. A massive 20% of the world's semiconductor design engineers are Indian. While India hasn't traditionally manufactured the physical chips, its huge talent pool working in Bengaluru R&D centers for tech giants like Intel and Qualcomm has been designing these highly complex architectures for years. So India's hidden advantage is that it's finally connecting its brilliant, world-class design capability with its newly funded domestic manufacturing ambitions.
As we wrap up this explainer, I really want to leave you with a few key mental hooks. Keep these terms in mind as you watch this whole story unfold over the next few years. Remember, the India Semiconductor Mission, or ISM, the massive PLI scheme making it all financially viable, the fabrication plants, or fabs, being built right now, and of course, the ultimate goal, absolute supply chain resilience in a highly volatile world. Which brings us to our final thought. India undoubtedly has the world's class design talent, right? And it now has the massive state and private capital. But the trillion-rupee question remains. Can it flawlessly execute the most complex manufacturing environment on Earth to actually secure its technological future? Well, only time will tell, but it's for sure going to be a fascinating journey to watch. Thanks for joining me on this explainer, and keep learning.